Good morning, students. Class 10. How are you? Fine. Okay. I too am fine. And I hope you all will be safe and happy at your home. Students, come to the point. Already topic has been written here, and topic is how metals and non-metals react. So far, students, we studied about the chemical properties of metals and non-metals, and also in my last video I discussed before you about the amphoteric oxides, and today's topic how metals and non-metals react. Student, first of all, I would like to show here examples of some of the compounds made from metal and non-metal. For example, you can see and you are familiar with this compound NaCl. This is known as sodium chloride. In the similar way, CaCl2. This is calcium chloride. In similar way, MgCl2. This is magnesium chloride. And in similar way, Fe2O3. This is ferric oxide, and also Al2O3, which is aluminum oxides. Students, these all are example of compounds made from metal and non-metal. As you are looking here, and also you are familiar, sodium is a metal and chlorine is a non-metal. In similar way, calcium is a metal, chlorine is a non-metal. In next example, magnesium is metal and chlorine is non-metal. In Fe2O3, Fe is metal, oxygen is non-metal, and aluminium is also metal, and oxygen is also non-metal. So these all are example of compounds made from metal and non-metal. And this is the topic of today. We have to learn here how these two different types of atoms combine together, react together, and forms compounds like them. Means we have to learn here how sodium chloride is formed, how magnesium chloride is formed, how calcium chloride is formed, aluminum oxide is formed. We have to learn here in this topic. So students, first of all, my question from you is that why an element combine? Why two elements react together? What is the lust of that reaction? Why they react together? Can you tell me what is the reason behind it? Why elements react together? Yes, students, let me say element combines with another element to attain the stability. Elements combine together to attain stability. Now question arises, what does stability mean here? Students, an element becomes stable when in the outermost orbit of its atom either there is or are 8 electrons like nearest noble gas, like noble gases. Students, you are familiar with the electronic configuration of elements, and also you are familiar with the noble gases. For example, neon. Neon is a noble gas and its atomic number is 10. In the similar way, argon is a noble gas and its atomic number is 18. Now students, if you write the electron configuration of these two elements, let me write first orbit 2, second orbit 8. First orbit 2, second orbit 8 and third orbit also 8. So students, in case of sodium, L is its outermost orbit, and in case of argon, M is its outermost orbit. And you are looking here, in the outermost orbit of these two elements, there are 8 electrons. There are 8 electrons, and you can say the outermost orbit of these atoms are completely filled up with the electrons. Because in outermost orbit there cannot be more than 8 electrons. So already they have 8 electrons in their outermost orbit. So they need not to react with any other. And that is why they are considered as a stable electronic configuration, and these elements are said to be noble gases or inert gases. Noble gases or inert gases are those elements which has or have completely filled up outermost orbit, and in outermost orbit as cannot be more than 8 electrons. So you can say their outermost orbits are completely filled up. And that's why, due to completely filled up outermost orbit, these two elements need not to react. So students, all other elements try to attain the electronic configuration like these noble gases. So all elements tend to attain 8 electrons in their outermost orbit so that they can be stable. Okay, so students, the region of reaction of elements is to attain 8 electrons in the outermost orbit so that they can attain the stability of their nearest noble gases. So all elements try to attain the electronic configuration of nearest noble gas, and that is why an element reacts with another element. So you are learning here why elements react. So you can say element reacts to attain the electronic configuration of its nearest noble gas, because electronic configuration of nearest noble gas is supposed to be a stable electronic configuration, and that's why all elements try to attain such type of electronic configuration. Okay, so you learned here why elements react. As students, metal and non-metal both are elements. So now we have to learn here, being elements, how atoms of metal and atoms of non-metal react together and form compounds like NaCl, like MgCl2, like AlCl3, like Al2O3. Okay, so this is the topic. Students, elements to attain the electronic configuration of nearest noble gas, follow two paths. Follow two paths. So, students, atoms of metal and atoms of nonmetal can attain their nearest noble gas electronic configuration following two paths. And two paths, what are those two paths? First path, either they lose electrons or they gain electrons from other element. So first path is transfer of electrons of outermost orbit. This is the first path. And second path is sharing of outermost orbit electron with other element. Okay, so two paths, atoms or elements follow to attain the electronic configuration of nearest noble gas. Either transfer of electrons of outermost orbit or sharing of electrons of outermost orbit. Okay, now students, if elements or atoms transfer the electrons to the other atoms or elements to attain the nearest noble gas electronic configuration, in such case a bond develops between the atoms, and that bond hold the two different atoms together in that molecule, and that bond is said to be ionic bond. Ionic bond. Ionic bond. Right? So ionic bond is formed by the transfer of electron from one atom to another atom. Means one atom transfer its electron to another atom and another atom gain that electrons, and in this way between both a force of attraction develops, and that force of attraction hold them together in the molecule. So that force which hold them together in the molecule is said ionic bond. Right? Ionic bond. Number two, take other case. Students, if atoms or elements share its or their outermost orbit electrons, in that case also a bond is formed between them, and that bond is said to be covalent bond. Covalent bond. So students, these two types of bond, by making these two types of bond, elements combine together and form different compounds. Okay, so students, our topic of today is reaction of metals and non-metals. Means we have to study here how metal and non-metals react together. Students, you well know metals lose electrons during the reaction and form positive ion. For example, suppose this is a metal, and this metal during the chemical reaction lose its electron. Suppose it is losing here one electron, so you can show this in this way, right? Students, now that loosed electron is gained by a nonmetal, and this forms a minus ion non-metallic ion, and this is metallic ion. Okay, so metal lose electrons and form positive ion. Non-metals gain that electron and form negative ion. And now you are looking here between these two metal and non-metal atoms. Two oppositely charged ions form by transfer of electron or by lose or gain of electron. Now these two types of ions create a force, and that force hold these two atoms together by a strong Coulombic force of attraction, and this force is known as ionic bond. So students, in case of compounds made from metal and non-metal, there exists ionic bond. An ionic bond is formed by the transfer of electrons between two or more than two metallic and non-metallic atoms. Okay, so all the compounds made from metal and non-metal have ionic bond. And ionic bond, students, is also known as electrovalent bond. Why electrovalent bond? Because in formation of this bond, electron of valence shell are either loosed or gained. Okay, so due to lose or gain of electrons of valence shell, this bond is also known as electrovalent bond. Right? Students, the compounds in which ionic bond exists is known as ionic compound. So you have to keep in your mind, compounds made from metals and non-metals are said to be ionic compounds because in all of them ionic bond exists. Okay, is it clear now? Ionic bond exists. So compounds of metal and non-metal have ionic bond, right? So in brief, here about ionic bond, the bond which is formed by the transfer of electrons between two or more metallic and non-metallic atoms. Metallic and non-metallic atoms are known as ionic bond. Okay, right? So compounds made from metal and non-metals are said to be ionic bonds because of containing ionic bond. All of them have ionic bond, and ionic bond is formed. Why do you think why this bond is said to be ionic bond? Because in this bond is formed by lose or gain of electrons. Metallic atom lose electrons and form positive ion. Non-metallic atoms gain that electrons and form negative ion. So two different type of ions form in this process, and that hold them together. That ion hold them tightly in the molecule. So ionic bond is due to formation of ions. Means in such compounds two opposite ions are present, and that is why this bond is said to be is known as ionic bond. Okay, now students, covalent bond. Covalent bond. Covalent bond, student, this bond is formed between two or more non-metallic atoms. Means in the formation of this bond, non-metallic atoms take part. Not metal and non-metal, non-metallic atoms. Between non-metallic atoms, such bond exists. Right? So students, some important about covalent bond. The bond which is formed by sharing of, which type of sharing? Mutual sharing, by sharing of electrons between two or more non-metallic atoms, two or more non-metallic atoms or elements, is known as covalent bond. So you have to keep in your mind, covalent bond exists between the compounds made of two or more non-metallic elements. For example, students, NH3, which is read as ammonia gas, NH3. Students, ammonia, in this compound, N is also a nonmetal and H is also a nonmetal. So certainly in this compound the bond is covalent. Right? In similar way, another example, CCl4, which is read as carbon tetrachloride. So students, carbon is a nonmetal, chlorine is a nonmetal. So also in this compound the bond is covalent, right? So you have to keep in your mind, covalent bond exists between the compounds made from two or more than two non-metallic atoms. Okay, now how this bond is formed? So students, in this bond between both atoms, mutual sharing of valence electron take place. By mutual sharing, why mutual sharing? Because here lose or gain is not possible. Lose or gain is not possible. You can understand this by here one example. For example, nitrogen. As you know, atomic number of nitrogen is 7. So electronic configuration 2 and 5, and hydrogen is 1. So its electronic configuration is 1. Now students, you can see here, no one can lose its electron. Means both of them require electron to attain the nearest noble gas electronic configuration. So students, in case of nitrogen, you are looking here in the outermost orbit, there are 5 electrons. So students, to become stable, it needs 3 more electrons. Means nitrogen is required here 3 more electrons to become stable like its nearest noble gas, and the nearest noble gas of nitrogen is neon. So from the electronic configuration of neon, it has less than 3 electrons. It has electrons 3 less than neon. And also in case of hydrogen, you are looking here, there is 1 electron. and its nearest noble gas is helium, and you know helium has 2 electrons in its outermost orbit. So students, hydrogen also requires here one more electron to become stable like helium. So both are in need of electrons. No one is here in position of lose of electrons. So both are needy here, and that's why between them what happens, they follow second path to become stable, and second path is mutual sharing of electrons. They share their valence electrons, and in this way they get a stable electronic configuration. For example, you can see here in ammonia there is one atom of nitrogen and three atoms of hydrogen, which I show here like this. Now valence electron of hydrogen 1, 1, 1, and valence electron of nitrogen is 5. So 2, 1, 1, and 1. Right? And now students, mutual sharing. You can see here hydrogen is sharing one electron of nitrogen. Also this hydrogen is sharing one electron of nitrogen. Also this hydrogen sharing one electron of nitrogen, and in this way you are looking here, hydrogen has now become 2 electron and it has become stable like helium. Now is the turn of nitrogen. So nitrogen only has 5 electrons and it requires 3 electrons. So one electron from each hydrogen nitrogen shares, and in this way you can see here nitrogen also acquires 8 electrons in its outermost orbit. Okay, so students, you are looking here between nitrogen and hydrogen there is mutual sharing of one electron each. So you can show this like H single bond N, also here single bond H, here also single bond H. And students, these 2 electrons on nitrogen is such that it directly does not involve in sharing of electron. So this is unshared electron upon nitrogen. And students, this unshared electron upon nitrogen is known as lone pair electron. Lone pair electron. Right? So what is lone pair of electron? So you have to say the electrons which does not involve in mutual sharing is known as lone pair electron. And in this way, students, you are looking here covalent bond. These all are covalent bond, covalent bond, covalent bond. So in ammonia, these are the covalent bond. Okay, right? Students, keep in mind one thing: formation of covalent compound, you have to show the sharing of electron in this way, because they mutual share their electron, and sharing is shown by enclosing the valence electron like this, right? Okay, so this is the covalent compound. So compound in which covalent bond is present, that is said to be covalent compounds. Okay, okay. Now students, for today this is all. In my next class I will talk with you about the some important properties of both the types of chemical bond, means ionic bond and the covalent bond. Okay, but here once again keep in mind, metals and non-metals compounds are ionic and non-metal compounds are covalent. Okay, thank you very much.